Hey everybody, welcome back to another riveting math lesson with Mr. Bunt. And today's math lesson will be for Wednesday, and it is lesson 15. And it is the same objective as what we did on Monday. And the objective is I can solve real-world problems involving area of figures with fractional side lengths using visual models and or equations. Today's lesson is a little bit more challenging than what Monday's was. If we were in the classroom right now, I would probably put you kids in groups and have each of your groups work on a separate problem, and then we'd all come back together to take a look at what we did. It's that kind of lesson. So this is going to be a challenging one. So what I'm going to do is I'm going to go through each problem with you in your problem set. No whiteboard work today, and I'm just going to go through each problem and give you a head start on it. So I am on pages, so I'm going to go over pages 212, 213, and 214 in your math workbooks. So here's the first one. It says the length of a flower bed is 4 times as long as its width. 4 times as long as it is wide. If the width is 3/8 meter, what is the area? So the width, we're going to draw the width, and it's going to be 3/8 of a meter. Now, this line represents this amount. So if you're thinking about repeated addition, if we did 3/8 plus another 3/8 plus another 3/8 plus another 3/8, that'd be 4 times. So imagine if we had little lines separating these. 1, 2, 3, 4 3/8. That would mean that the length is now 4 times this. So we have 3/8 of a meter, 3/8 of a meter, 3/8 of a meter, and 3/8 of a meter. Now, your job is to find the area of this flower bed. So what you need to do is, you need to, first step, you can do 2 different things. You can add 3/8 plus 3/8 plus 3/8 plus 3/8, or you can just simply multiply 4 times 3/8. This will get you your length of the flower bed, and then your answer that you get here, then you will multiply by your width, which is 3/8. So 2 steps to this problem here to find the area. Your answer is going to be meters squared. We're talking area here, 2 dimensions. So that's number 1. The rest is on you. Number 2, Mrs. Johnson grows herbs in square plots. Her basil plot measures 5/8 yards on each side. So we have a basil plot here. 5/8 of a yard on each side. So just because we're dealing with area here, I'm just going to draw, I'm going to label 2 side lengths here. And your job for letter A, find the total area, the basil plot, just multiply 5/8 times 5/8. Multiply those 2, and you will get your answer. And your answer is going to be in yards squared. So that's a nice easy one to start. Level 2 type problem. Gets a little more challenging. Mrs. Johnson puts a fence around the basil. If the fence is 2 feet from the edge of the garden on each side, what is the perimeter of the fence in feet? This is where it gets a little challenging here. So it goes 2 feet. I'm going to draw, let's see, I draw an arrow there. 2 feet here. And it goes 2 feet there, and it goes 2 feet there, 2 feet there. So we have to figure out the perimeter of the entire fence. Now, here's the thing with this one, is you'll have to first figure out, you're going to have to convert 5/8 into feet. All right, so in order to do that, 5/8 times, we're going a larger unit to a smaller unit. So you have to think about how many feet are in a yard, and that is 3 feet. So then, since you're going to a smaller unit, we're going yards, this is yards, to feet, you're going to actually have to multiply by a fraction. That is 1/3. And then from there, you'll figure out, let's see here, times 1/3. Oh, my bad. Sorry, you're going to multiply, sorry. You're going to feet. You're going from a larger unit to a smaller unit, sorry. So it's going to be a whole number, my bad. So it's going to be 5/8 times 3. Once you do that, you'll figure out 5/8 yards in terms of feet. So what you'll have now, let me kind of just recreate the drawing up above. So once you get the answer here, you'll have your new length right here. And then you'll also have from here to here 2 feet. And then from here to here you'll have 2 feet. So once you figure out the answer to 5/8 times 3 and get your new answer from yards to feet, we're converting, then you just add them all up. So now you end up getting the length. Once you do that, once you add up these 3 numbers, you'll get your length. And now that you're finding perimeter, the perimeter is the distance around an object. So from there, you can do 2 things. You could add your length 4 times. So you have a length, say you get 5. Then you could add another 5, another 5, another 5, and get your perimeter. Or you can just multiply what you get here by 4. All right, hopefully that makes sense. But yeah, with conversions, just remember when you're going from, this was yards, if you're going from a larger unit to a smaller unit in terms of your converting, you're going to have to multiply by a whole number. If I was going the other way, then it would have to be multiplied by a fraction. So there's some help there with B. And then C, and that's where they ask you to, it says, what is the total area in square feet that the fence encloses? So from here, once you get your length, whatever you get for your length, then you're going to have to get your width as well. And all you're going to have to do is just do length times width. Because all it's asking for, I want to again redraw the diagram. There's the basal. They're just asking for the fence. So once you get L on the previous problem, all right, then it's going to be the same number as your width. So just multiply those two together. So whatever you get for this answer in the previous problem, just multiply it by itself again, and then you'll get the area and the answer for letter C. Okay, moving onward. Number 3, Janet bought 5 yards of fabric, 2 1/4 feet wide to make curtains. She used 1/3 of the fabric to make a long set of curtains and the rest to make 4 short sets. A says find the area of the fabric she used for the long set of curtains. So we know that the curtains are going to be 2 1/4 feet wide. Now, if you decide to do the area model in the end, make sure you break apart 2 1/4, so you have partial products. Now, the length, you would say, oh, it's 5 yards. Well, no, we need to do some converting. This is why this problem set, this lesson in general, is just a little bit more challenging, because you have to do an extra step of converting, and you have to realize that. So 5 yards is how many feet? Well, if you know that there are 3 feet in a yard, like we talked about previously, it's just going to be 5 times 3. So your length is going to be 15 feet. Now your dimensions are the same. Now you can multiply to figure out your answer for letter A. And that's the area of the long curtain. Your answer is going to be in feet squared. Now it says find the area of the fabric she used for each of the short sets. So in this case, what you'll need to do, let's see here. Okay, so you're going to take your Okay, yeah. You're going to take your answer for letter A. So let's just say answer to A. We'll just put parentheses around it. You're going to take your answer to A, and then what I want you to do is subtract it. You're going to subtract it from 11 1/4 feet squared. All right? So now you ask yourself, well, how'd you get that? Well, what I did was I multiplied 33 times 1/3, and then I also multiplied 3/4 times 1/3 when it came down to whatever I got an answer here. There's an extra step. So what I'm doing in this scenario is actually giving you just a little help because I want you to just do the basic stuff, and I don't want to make it any more complicated than it is because I know these story problems are so difficult. So trust me on this one. Whatever you get for an answer here, go ahead, plug it into here, and then subtract 11 1/4 feet. This is the area of the long curtain, but I wanted us to, I wanted us to really find the total area of the fabric, if that makes any sense. So technically, this is your answer for A, but I want you just to find I just want you to find the total area of the entire fabric Janet uses, and then we'll be able to find the short sets. All right, and then we have one more. And it is problem 4. And for problem 4, you don't have to do letter B. If you want to try, make it a really challenge yourself, go ahead. But I'm only requiring you to do letter A. It says number 4, some wire is used to make 3 rectangles, A, B, and C. And if you have room on your paper, I want you to draw your rectangles like so, progressively getting a little larger. All right. It says, and this is a perfect story problem where you actually have to read the whole thing and figure out what comes first, because the first piece of information you might not need until the last sentence. Rectangle B's dimensions, length and width, are 3/5 centimeters larger than rectangle A's dimensions. Rectangle C's dimensions are 3/5 centimeters larger than rectangle B's dimensions. We don't know those dimensions yet, but we do know this. We do know that rectangle A is 2 centimeters by 3 1/5 centimeters. So you can write them however you want, length and width. Now, it's asking you to find the total area of all 3 rectangles. Your job now is to figure out what is the length of B and what is the width of B. Also find out what the length of C is and what the width of C is. It says that B is 3/5 centimeters larger for both dimensions. So to find the length for B, you're going to have to do 3 1/5 plus 3/5. And for this one, you add 2 plus 3/5. That's your width for B. Now, whatever you get for these answers, then for the length of C, you're going to take B's width, and I'll just write it like so. Or sorry, the length. The length, and then add 3/5 there. And then for the width of C, you're going to have to, whatever you got for an answer there, take B's width. There we go. And then add 3/5 to that. Once you get these dimensions, then you're going to have to multiply to figure out the area of A, multiply to figure out the area of B, and then multiply to figure out the area of C. Then when you do that, in the end, you're going to take your area for A, area for B, and area for C, and then add them all up to get your final answer, and your final answer is going to be centimeters squared. So I gave you a little jump start on this problem here, and it's your job to do the rest. Again, this is a very challenging math lesson that would require quite a bit of time, and you have a ton of it right now. So make sure you're really critically thinking and putting in the effort to really slow yourself down and not rushing. You don't need to rush now. You have all the time in the world, but I gave you a huge jump start on all these problems because they are so challenging. I'll be looking at your answers if your parents decide to send them via Class Dojo, and I'll see what you end up getting. But this is some challenging problems, and if we were in the classroom, this would probably be a group assignment, and then a group share and see what we got. But this is what we got to do. So we're all in on our own right now. Okay, that is the end of lesson 15. Again, the objective is I can solve real-world problems involving area of figures with fractional side lengths using visual models and or equations. The main thing about these lessons that I've taught you this week, kids, is do you know how to find the area of a particular object, in this case a rectangle, that is in a mixed number form, like this, for the length, and a mixed number form like that for the width. Can you find the area of this rectangle? And yes, you can. You need to multiply those two numbers together. We've talked about many strategies, and when you do that, you will get your answer. And if it was in meters, then of course our answer would be in meters squared. All right, good luck with this lesson, and let me know if you have any questions, and then I will see you for Friday's math lesson. And Friday's math lesson, we're going to be getting into back into some geometry with angles and lines and some fun stuff. So really hang in there with this final lesson, and I promise you Friday will be a little bit less daunting for you kids. All right, this is Mr. Bunt signing off. Have a great rest of your day, and keep working hard on math, kids. See ya.